Hello everyone, welcome back to the channel Chemistry for IIT-JEE. Today we are going to take one question from FIITJEE AITS 11th held on 28th May. This question is from paper 2, that was section A, where we are having MCQs, and that question was from one or more than one correct questions. Here we go. So this question was basically about the electrophilic addition. Type 1 we are referring to when we are having the free carbocation present. That is the meaning of type 1. So whenever we are having free carbocations present, there are always possibilities of rearrangement. And this time there is one, usually there are alkyl groups present. This time there is one CF3 group present, the first option. So they had asked for the correct product. In which of the following we are having the correct product. Now, the first question, when we are going ahead with the addition of H plus, we are understanding that CF3 will be undergoing the addition of H plus first. So double bond is going to be added over there. Now we'll be having some intermediate carbocation. We know that carbocation will not be stabilized onto this particular carbon because that will be highly destabilized by a very strong electron withdrawing effect of the CF3, which is coming from the reverse hyperconjugation. So it was expected that the carbocation is being formed over here onto this carbon, but probably it was assumed that positive charge is coming over here. And then Br addition is taking place. Bromide ion addition taking place, and we are getting this one as the measured product. But there is a little problem in this part. We'll be discovering this thing in detail, and going to the other options. If we try to see, this is the alkene undergoing the peroxide reaction with peroxy acid, so epoxide formation will be taking place. So the first step over here was the formation of epoxide, which upon acidic hydrolysis, because we have put acidic medium, so this is going to be the anti-addition of OH, giving you overall anti-hydroxylation. So this is not the major product. Major product would have been if this one of the OH was on the opposite side. In the option number C, when we are doing hydration, catalytic hydration, this is once again the carbocation which we are assuming to be formed in the very first step. This is 2-degree carbocation. This will be now rearranging into relatively more stable carbocation. That's going to be the positive charge on the 3-degree, and there OH minus would have been attacking. So rather than OH being present over here, if this OH was present onto this carbon, this would have been the measured product. So this is also not the correct answer. This is also not the correct answer. Option number D was addition of bromine in presence of CCl4. This is going to be the anti-addition, very much famous reaction. We have seen it a variety of places. So the first thing was the generation of bromine giving us the cyclic bromonium ion, and then another bromide ion would be attacking from the other side. So this is going to give you anti-addition of the bromine. Either this bromine comes from the bottom or this bromine comes from the top. This is going to be the correct answer. Now, the answer to this question, as per given by the key, was A and D. There is no problem in D at all. There is no problem in B and C, but there is something which is wrong in the A. A is not expected to be the major product. Why we are saying so? So A, although it was given as the answer in the answer key, actually it should not be the answer. Here is the rationale behind that. So what we expect is this one should have been the major product. And why we are saying so, we have reasonings of the stability of the carbocation intermediate, what is being formed, that we can realize on the energy profile diagram for the reactions as well. So let us have look at what are the intermediates involved and how this reaction can be progressing, and then we'll come back to the energy profile diagram as well in a moment. So when we are saying that addition of H plus is going to take in the very first step, the reaction is going to progress this way. So CF3 is going to, this double bond basically is going to attack onto the H plus. Now, as usual, we are expecting the positive charge will be formed over here rather than being formed there, because there is too strong reverse hyperconjugation that's very, very electron demanding. The positive charge on the carbon will be very, very destabilized. So we are getting the positive charge formed onto the other carbon. Now what? Because this positive charge is having 3 alpha hydrogen and relatively strong minus I effect. If this is rearranging by a hydride shift from here onto there, what we will get, this is 2 degree again, but this is having one extra alpha hydrogen. This is going to have 4 alpha hydrogens, and this is relatively now weak minus I effect coming from this CF3 group, right? So this is definitely going to be better, and whenever we have seen if there is a more stable carbocation about to be generated, this is going through that energy profile diagram, and the more stable carbocation is actually being generated in those cases, right? Okay, then if you see here, we are having 4 alpha hydrogen, that is fine, this is better than the earlier one. But here we are still having a relatively more destabilizing effect coming from the minus I, because if this also undergoes rearrangement over there, then this is again having 4 alpha hydrogen present, but this is having even weaker minus I effect. So if this is even weaker minus I, this can be the most stabilizing effect. That is, we can say, most stabilized carbocation. And as we understand, whenever reactions are happening, if there is nothing like thermodynamic versus kinetic control, then the most stable intermediate is supposed to be giving us the major product. So this one is the most stable carbocation. Now here, when Br minus ion would be attacking, we will be getting this one as the actually major product, right? If we had to choose from these two options, like if they had given CF3 and Br, this was one of the options and this was another option, then it is true this one is going to be major in comparison to the first one. But if you have all other possibilities, the bromine coming on this carbon, bromine coming onto this carbon, if you put all the possibilities into consideration, then without any doubt, this one is going to be the major product. We can visualize this thing on the energy profile diagram as well. Here is the energy profile diagram. So we are having CF3 and HBr. This is the relative, what we can say, the free energy for these two reactants. And then with this pi bond is being broken, HBr is going to be attacked. This is the transition state. The very first carbocation we have generated onto this side, because if you want to generate on this 3-degree carbon, this energy profile diagram may be requiring even higher energy, passing through even higher energy profile diagram. So we have not already done that. We cannot think of generating this kind of carbocation where hydrogen can be going over there and CF3 can be going there. So this possibility we are not considering. This possibility is going to be very, very less likely. Now, whenever we have got one given carbocation, we are having a possibility of moving down the energy coordinate. These kind of reactions we have seen always happening in the carbocationic rearrangement, where 1 degree was converting into 2 degree, 2 degree was converted to 3 degree, or things like that. Or maybe some non-resonance stabilized carbocation converting into resonance stabilized. The idea was energy was driving all these reactions. So as you are going down the energy profile, the carbocationic rearrangements were taking place. All the way we have seen that. All the rearrangements were taking place when you are going towards lower energy profile diagram. And here we don't have any problem saying that this is the most stable carbocation, because from the earlier one, 4,3 alpha, 4 alpha, 4 alpha, this is the weakest minus I. That is the situation. We are saying the most stable carbocation now attacked by Br minus ion is going to give us this one as the major product. So answer to this question should have been changed to just D and not the A and D. So that's the discussion for this electrophilic addition reaction. I hope you realize that when CF3 is present, very strong reverse hyperconjugation is not going to give you reaction as per Markovnikov addition, because Markovnikov addition is working in very simple cases where we don't have any possibility of rearrangement, or we don't have any electron demanding groups which can be very strong electron withdrawing or very electron donating. In all those conditions, Markovnikov rule was going to fail. This was one such example where it was not just very strong reverse hyperconjugation of CF3. This is also the stability of the carbocations being governed by these different factors. And as you might have realized, whenever we are trying to decide the stability of the carbocations, or in number of different places, in general we have seen resonance effect is going to be much more dominating in almost all the possibilities in comparison to hyperconjugation, which is quite dominating over inductive effect. One or two exceptions we know although for that, but this is going to be a guiding principle throughout these reactions, throughout these reaction mechanisms as well. Okay, that's all for now. Thank you. Bye bye. See you next time. Stay safe. Bye. See you.